So in this video, let us look at still more advanced compound angle formulas. So you have already studied the basic compound angle formulas, which is sin A plus B, sin A minus B, cos A plus B, cos A minus B, tan A plus B, tan A minus B, cot A plus B, cot A minus B. So now the next set of formulas are sin A plus B into sin A minus B is nothing but, so what is sin A plus B? Sin A cos B plus cos A sin B into sin A minus B is sin A cos B minus cos A sin B. That is equal to this of the form A plus B into A minus B. That is sin square A cos square B minus cos square A sin square B. So now I'll try to convert the whole formula into simple signs. That is equal to sin square A times cos square B is nothing but 1 minus sin square B minus cos square A is nothing but 1 minus sin square A times sin square B. That is equal to sin square A minus sin square A sin square B minus sin square B, minus into minus becomes plus sin square A sin square B. So these two are getting cancelled. So that is equal to sin square A minus sin square B. This is a very important formula. Sin A plus B into sin A minus B can be written as sin square A minus sin square B. So if I write the sin square A as 1 minus cos square A and this as 1 minus cos square B, this formula can be converted completely into cos also, which will be cos square B minus cos square A. So sin A plus B into sin A minus B is sin square A minus sin square B, and is also equal to cos square B minus cos square A. Now the next formula is cos A plus B into cos A minus B. So cos A plus B is cos A cos B minus sin A sin B times cos A cos B plus sin A sin B. So if you try to simplify this, so you get cos square A cos square B minus sin square A sin square B. So in this formula, if you try to completely convert this whole formula into signs, it becomes complicated. So what I do is, I'll do half of. That is, cos square A into cos square B is 1 minus sin square B minus sin square A times what I do is, sin square A is 1 minus cos square A times sin square B. That is equal to cos square A minus cos square A sin square B minus sin square B plus cos square A sin square B. So this and this gets cancelled. So you get cos square A minus sin square B as the answer. So if you have cos A plus B into cos A minus B, you have cos square A minus sin square B. You have two different ratios. This can also be written as, if you write this as 1 minus sin square A, 1 minus cos square B, you can also write it as cos square B minus sin square A. It can be equal to cos square A minus sin square B or cos square B minus sin square A. So these are very important formulas. Sin A plus B into sin A minus B is sin square A minus sin square B or cos square B minus cos square A. Cos A plus B into cos A minus B is cos square A minus sin square B or cos square B minus sin square A. The next set of formulas that you have are sin of A plus B plus C is equal to sin A cos B cos C plus cos A sin B cos C plus cos A cos B sin C minus sin A sin B sin C. That is, you have one sin and two causes in each of the term minus all signs. Similarly, cos of A plus B plus C is, it starts with cos A cos B cos C minus all the terms containing single cos and two signs. Cos A cos B cos C minus sin A sin B cos C, sin A sin C cos B, sin B sin C cos A. And tan of A plus B plus C is tan A plus tan B plus tan C minus tan A tan B tan C by 1 minus tan A tan B plus tan B tan C plus tan C tan A in bracket. So these formulas are very easy to derive. you're encouraged to derive this. What you just need to do is, just need to take B plus C as an entity in the starting. Now you have two angles, sine of A plus B plus C. So you can expand the formula, the formula of sine of A plus B, that it becomes sine A cos of B plus C plus cos A sine of B plus C. And in the next step, you just use the formula for sine of B plus C and cos of B plus C. And if you simplify, you get the formula here and here. Here also you do the same thing, B plus C. Take B plus C as an entity in the starting and apply formula of tan of A plus something. And in the next stage, apply the formula for tan of B plus C. So I hope you can derive this equations formulas very easily. So the final set of formulas that you have in this topic are sine of A1 plus A2 plus A3 so on up to AN. We have a compound angle of n different angles, A1 plus A2 plus A3 so on up to AN, and cos of A1 plus A2 plus A3 so on up to AN, and tan of A1 plus A2 plus A3 so on up to AN. So these are the three formulas which you have in the final section. So the first formula is cos A1 cos A2 so on up to cos AN times S1 minus S3 plus S5 so on. Cos of A1 plus A2 plus A3 so on up to AN is equal to cos A1 into cos A2 so on up to cos AN times in the bracket 1 minus S2 plus S4 minus S6 so on. And tan of the compound angle is equal to sine of this by cos of this. If you divide these two, cos terms gets cancelled. So you have S1 minus S3 plus S5 minus S7 by 1 minus S2 plus S4 minus S6 so on. And where what S1 is the terms that we have used here, S1, S2, S3, S4 so on. S1 is the sum of all the tans of individual angles, that is sigma tan of AI is nothing but tan of A1 plus tan of A2 plus tan of A3. So this sigma represents continuous summation. So tan of A1 plus tan of A2 plus tan of A3 so on up to tan of AN. This is nothing but sigma tan AI. So this is nothing but S1. Now what is S2? S2 is nothing but sigma of tan AI tan AG. That is the summation of the product of two tans taken at a time. And here we take I less than j. That is tan A1 tan A2 plus tan A1 tan A3, all the possible products of two terms, plus so on. All the possible terms, all the possible products of two terms such that I is less than j. That is, you should not take tan A1 tan A2 as well as tan A2 tan A1. You have to go in only one direction. Similarly, S3 is the sum of products of three angles taken at a time. Tan of three angles taken at a time. S4, four angles taken at a time. As you go on more and more, the number of terms that you need to consider increases. So for example, if you have tan of A1 plus A2 plus A3 plus A4, that is, you have four angles. So the formula will be equal to some numerator by some denominator. In the numerator you get odd S1s. In the denominator you get 1 and even S1s with an alternate plus minus sign. And you have four angles, so the maximum S goes to S4. Now what is S1? S1 is nothing but sum of all tans individually. That is sigma tan AI. That's nothing but tan A1 plus tan A2 plus tan A3 plus tan A4. So this will be the value of S1. So now S2 is equal to, we have already written this as sigma of tan AI tan AJ. You have to take the product of two tans at a time where I is less than j. So what you get is I can go from 1 to 4, j can also go from 1 to 4, but I has to be less than j. So you get tan A1 tan A2 plus tan A1 tan A3 also, plus tan A1 tan A4 plus, so with A1 I have taken A2, A3 as well as A4. Next, tan A2 times tan A3 plus tan A2 times tan A4. So with A2 I have taken A3 and A4 also, plus tan A3 times tan A4. So I have taken all the possible terms where I is less than j. So if I take tan A4, I won't have a second tan which is greater than 4. So you have a total of 1, 2, 3, 4, 5, 6 terms. That means out of 4 angles, you're taking 2 angles at a time. That is 4C2 terms. If you have the knowledge of basic permutations and combinations, we know that out of 4 things, if you have to select 2 things, you can do it in 4C2 ways. So here I less than j implies there are no arrangements, we are just taking selections. So tan A1 tan A2, but I'm not taking tan A2 tan A1 again. So whatever is the product, we just need to take it once. So here I can also use I greater than j, there is no problem, I get the same terms, but you should not repeat the terms. Similarly, S3 is nothing but sigma tan AI tan AJ tan AK, where I less than j less than k. Here also, that means you fix the order of I, j and k. So you cannot take different arrangements of I, j, k. So out of 4 angles, you're taking 3 angles. So the number of ways in which you get different terms is nothing but 4C3. That is equal to, you get 4 terms. So that is nothing but tan A1 tan A2 tan A3 plus tan A1 tan A3 tan A4, this is also okay, plus tan A1 tan A2 tan A4, this is also okay, right? Because I is less than j is less than k, plus tan A2 tan A3 tan A4. These are the 4 terms that you get in the term S3. Similarly, S4 is nothing but sigma I less than j less than k less than l tan AI tan AJ tan AK tan AL. So out of 4 angles, I am selecting all the 4 angles, so I can do it in 4C4. That is only one way. So S4 has only one term, tan A1 into tan A2 into tan A3 into tan A4. So these are the meanings of S1, S2, S3 and S4. And the number of terms that you get in each term can be calculated using the concepts of permutations and combinations. Here you have 4 angles and you're selecting one angle, so you get 4C1 terms. And this one can be thought of as S0 also. S0 has 4Z0 terms and there are no tans, so the number is 1. So S1 minus S3 by 1 minus S2 plus S4. So I hope the concept of S1, S2, S3, S4 is clear to you. Now let us move forward.